Hello everyone, welcome to Study Zone. Today I am going to explain the topic that is rules of quantified statements. So in the last video we have seen already about quantifiers, right? So there are two types of quantifiers. One is existential quantifier and one is universal quantifier. So in universal there will be like for all, every, like that, right? In existential quantifier there will be like at least, some, like that. So now we are going to see rules of quantified statements. Okay, so in rules of quantified statements there are four types, and first two is comes under universal quantifier and these two comes under existential quantifier. Okay, so in universal quantifier we have universal instantiation, we can also denote it as U I, and then universal generalization, we can write it as UG, right? And then existential instantiation, that is EI, and then existential generalization, that we can represent as EG. So let us go through them one by one. So before that, what is the use of these things? These are all used to solve predicate logic. Okay, so now don't worry about what is predicate logic and all. I will explain you what is predicate logic later. So remember these things. These four, these quantifier and all are used to solve predicate logic. Okay, so let us go through them one by one. Okay, the first type is universal instantiation, that is UI, correct? So here, if for all x, p of x is true, then p of a is true for a specific a. So the thing you should remember is, for all x, p of x is true. That is, for each and every element or object or term, p of x is true. Then p of a is true for specific a, which means if we take any one element, then it is true for that element. So let us take one example. Okay, all humans are mortal. They are telling all humans are mortal. So now, if all humans are mortal, then it is true that Socrates are mortal, right? So Socrates are one type of human being. So if all humans are mortal, then Socrates must be mortal, like this. Okay, so we can denote it as, for all x, p of x, that is true, then p of a is true. For all x, p of x, therefore p of a. So let us take one analogy, or let us take one daily life example to understand it clearly. Okay, so let us take the rules of a classroom. So here a teacher says that tomorrow everyone should submit their homework. So now John come here and ask the teacher, ma'am, should I also need to submit the homework? Then the answer is yes, because teacher told here everyone should submit their homework, right? So everyone means each and every member in the class. Here John, who is John? John is a student, right? So John is a student. So since teacher told everyone, since John is a student, John also must submit his homework. So here p of x is this one, which means it is true for each and every x. Then John is a, correct? So for any a, p of a is also true. Do you understand? So this is about universal instantiation. So let us go to the universal generalization. Okay, the next one is universal generalization, right? So this universal generalization suggests us that if p of a is true for all a, then for all x, p of x is true, which means here p of a is true for all a. For each and every possible value of a, p of a is true. Then we can tell it as, for all x, p of x is true. We are generalizing the statement here. Okay, so let us take an example. So if x is a bird, then x has feathers, correct? So let us take it as peacock, parrot, or any bird. All bird has feathers, right? So if x is a bird, then I am taking one peacock. Okay, that peacock is having feather. parrot, one parrot, okay, that parrot is also having feather. So we can write it as, we observe that every bird has feathers, which means it is true for one element or one object, then it is true for each and every object, that is universal generalization. So we can write it as P of A for arbitrary A, therefore for all x, P of x. So let us take one analogy for this. So here let us take, there are 5 students, okay. There are 5 students here. So here is Ram. So Ram is following one rule in the class, and Sita is also following this rule in the class. Ravan is also following that rule in the class, and Rohit also following that rule in the class, and Suresh is also following that rule in the class. So all are following the rule in the class, correct? So we can write it as, the rule applies to all, right? The rule applies to all, which means for all x, P of x, correct? So for A, P of A is true, for A, P of A is true, for A, P of A is true. So we can write it as, it is true for each and every element in the x. Is it clear? That is universal generalization. In universal instantiation, what we are going to do? We are telling that these 5 students are following the rule. So it is true for him also. So we are writing like that. But here we are telling that he is following, he is following, he is following, everyone is following. So it is true for all. Okay, be clear with that. Okay, the next one is existential instantiation. So at first, what is existential quantifier? Existential quantifier means for some, means it is applied for only some values or for at least one value. If it is at least one value, then it is okay, like that. So in existential instantiation, what it is telling is, if there exists x, P of x is true, then there exists a specific A for which P of A is true. So there exists P of x, which means there is at least one value that is true. So there exists, which means there is specific A for which P of A is true, which means there is at least one term for which A is true. So let us take one example to understand it, okay. You might feel it a bit confusing. Let us take an example and let us make it clear. So let us take, suppose we hear an announcement, okay. So the announcement is that there exists a dog that has been lost in a city. So what is the announcement? Dog is lost in the city, okay. Dog is lost in the city. So for all x, P of x, where P of x equals to x is a lost dog in a city. So we know that there is one dog lost in the city. We don't know, okay, this dog is lost, this dog is lost. We don't know that. We just know that some dog is lost in the city. Since we at least know one dog is lost in a city, right? So we introduce a specific but unknown dog. So we assume that we introduce one dog, right? So, okay, one dog is lost in a city. So we introduce one dog, which means not specifying, but one unknowing dog, and it's called as Bruno. So let us take it as P of Bruno, okay. So what do we say now? Bruno is a lost dog in the city. Therefore, Bruno is a lost dog in the city, correct? So there is one dog lost in the city. We don't know that it is Bruno, but we get to know that one dog is lost in the city, which means it is true for at least one dog. So we assume that dog is Bruno, so we will go to search for Bruno, okay. That is the thing, we have to find that it is at least true for one thing, and we have to search for it. That is existential instantiation. Clear? Now the last rules of quantified statement is existential generalization. Generalization means we are going to generalize something, okay. So it suggests us that if a statement is true for some particular individual A, Okay, what is it is telling? If a statement is true for some particular individual A, then we can generalize it as there exists some X for which this statement is true. Okay, so it is true for some individual A, then we can tell that okay, this is true for some individual, or it is true for some statement. Okay, so we can take the example so that you can understand it easily. So suppose take that there is one person named John. So John know about Python programming completely. Okay, John know about Python completely. So we can say that there exists at least one person who know Python. We are not telling John knows Python here. We are telling that there exists one person who at least know Python, which means here we know that there is P of John. But what we are going to do? We are generalizing it as there exists X, which means there exists at least one person, that is P of X, who knows Python. Like that we are generalizing. So this is about existential generalization. So in rules of quantified statements, we have seen about four types, right? One is universal instantiation, universal generalization, existential instantiation, and existential generalization. So go through the video of quantifiers also, that is there in the previous video, and go through this. So after clearing all these concepts, let's go to the predicate logic. So for this, thank you.